Okay, so for 7 times 4, we're going to investigate what happens when we divide by the same base. So we have 4 to the 5th, which is 4 times 4 times 4, with 4, 5 times. And then we have 4 to the 3rd, which is 4 times 4 times 4. We're going to go ahead and do the individual division. So I know 4 divided by 4 is 1. 4 divided by 4 is also 1. 4 divided by 4 is 1, and I'm just left with 4 times 4, which is equal to 4 squared. We're going to do the same thing with c to the 4th. We're going to put down 4 c's, and then for our denominator, we're going to put down 7 c's. And we're going to cancel 1 for 1 the c's that are on the top and the bottom. And in this case, I am left with 3 c's down below, so that is 1 over c to the 3rd. Now, how would I write that as a negative exponent? I'm going to write 1 over c cubed as a negative exponent. So when we pull up, what do we got, Connor?
Negative parentheses, or parentheses negative c cubed.
So when we move 1 from the, whether it's from the bottom to the top or the top to the bottom, the sign on our exponent changes. So we have, this is the same as c to the negative 3. Normally, I wouldn't end with a negative exponent. Normally, we would just say 1 over c cubed. But because we're investigating, I want to put that out there as an alternative so that we can find the pattern. All right, this is the hard part. We're going to go ahead and put down 12 x's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we're going to put down 5 x's. Cancel out the ones that repeat. We can run out after 5 of them. So we are left with 7 x's multiplied together. So take a moment, then let's think about what the rule is going to be when we divide the bases that are the same. Okay, so the rule for dividing our exponents, or this, when we're dividing the same bases, that we subtract the exponent. You are dividing powers with the same basis, subtract the exponent. So let's go ahead and we're going to create symbols to represent this statement. So I'm going to use the division symbol. To represent dividing. And yesterday I used my Thor hammer with the lightning to represent power. So when you're dividing powers with the same bases, I used my little home plate to represent the base, we subtract the exponents. So guys, take a moment and write your symbols above this statement. Or you can ask yourself, where do I have more? And how many more? So like in this x to the 12th problem, we have 7 more on the top than we do on the bottom. So the answer is x to the 7th. All right, let's apply that rule to these problems here. So we're going to start with x to the 3/2 and x to the 1. We're getting a little bit of a bonus here in the fact that they put the 1 down there. Normally they wouldn't have the 1, it would just say x, and we would need to know that we put a little 1 power on it. So we're going to go x to the 3/2 minus 1. Only problem with that is that we can't subtract fractions unless they have the same denominator. So I need to make sure that 3/2 has the same denominator as 1. So I'm going to convert the 1 into 2 over 2. This is a flashback to 5th grade that you thought you could just completely ignore and never have to see again. Unfortunately, fractions come back and they throw a punch you when you're not expecting it. So, whichever you find a common denominator, your bottom stays 2, your top subtracts. So 3 minus 2 is 1. So this is x to the 1/2. When you have more than one letter rolling around, you group the 2 letters together. So for here, I want M2 to be grouped with M5 and N4 to be grouped with N3. So when you have 2 different letters, group the letters together. If it doesn't have anybody to group with, you just keep it as it is. So this would be M2 minus 5 and N4 minus 3. M to the negative 3 and N to the 1. We don't leave our answers in negative exponents. We go ahead and throw that down to the bottom and cube, make it positive. So the answer to this second problem is N over M to the 3rd. So take a moment and try these problems on your own. For the first one, you should have gotten y to the 2/5. And if we group our 2 letters together, our A's with A's and our B's with B's, we'll get A to the negative 3 minus 5 and B to the 7 minus 2. And that is A to the negative 8, B to the 5th. We want to keep the positive ones on the top and the negative ones go down below, but with a positive power. The very last one is going to be 6 minus 1. So this is a scenario where they don't put the 1 down. And we have to know that it's k to the 6 minus 1. And we get j to the 2nd minus 5. 2 minus 5 is negative 3. So it goes down below to be a positive 3. All right, so now we're going to take our quotient and raise it to the powers. When you have multiplication or division, you can give everything inside the parentheses the power. So this is x to the 3 times 3 over 5 to the 3. When you raise a power to another power, the powers multiply. 3 times 3 is 9, and 5 times 5 times 5 is 125. And then for the next one, we're going to give everything inside. The 2 gets squared, the a to the 3rd gets squared, and the b squared gets squared. Everything gets that power 2. We know that 2 squared is 4, 3 times 2 is 6, and 2 times 2 is 4. So everything on there got it because the only thing separating each piece is multiplication or division. All right, you guys take a moment and try this with these two problems. You guys about 60 seconds to do that. All right, do a little check. Your answer to the first one should be 16 over x to the 6th. And your answer to the second one, I'm going to go ahead and do the division inside first. The second one should be a to the 8. Now we have the situation where you have a negative. We're raising it to a negative exponent. So let's see if we can come to a consensus here. So my x is going to get the negative 2, and my y is going to get the negative 2. So it's going to be x to the negative 2 over y to the negative 4. It is not okay to leave the exponent negative. I'm going to have to bump the x to the negative 4 up and the x to the negative 2 down. So essentially, I just switch my x and my y because they were both negative. Now they're both positive. Let's take a look at that scenario here. We have 2 to the negative 3, x to the 6, and it gets the negative 3 also. And my y to the 4 gets the negative 3. Everybody gets it, whether they want it or not. Let's simplify this down. It's 2 to the negative 3, x to the negative 18, because 6 times negative 3 is negative 18. And then y to the negative 12. We are going to flip-flop everything over here so they can have positive exponents. So my y12 is now going to be on the top and positive. 2 to the 3rd is on the bottom and positive. X to the 18. And remember, it is only the exponent that changes sign. The original number still stays 2. It doesn't become negative 2. It still stays 2. So one more simplification, and we can call this problem good. 2 times 2 times 2 is 8. So the complete answer is y to the 12th over 8 times x to the 8. All right, you guys take a moment and try that with this problem. All right, so let's give everybody this negative 2 power. We're going to give it to the a, to the 5, and to the b. I need to move all these, the 5 to the negative 2 and the b to the negative 2 up so I can make it positive. And I need to move the a to the negative 2 down so I can make it positive. Now I just have to do 5 squared. And I get 25b squared over a squared.